our lesson today, we're going to be talking about divisibility by 2, 5, and 10. What that means is determining whether numbers are able to be divided by 2, 5, or 10. Okay, so the statement we're going to start with is that all whole numbers with ones digit 0 are multiples of 10. So here are a few examples of whole numbers that have a ones digit 0. What multiple of 10 is each one? Well, 30 is 3 groups of 10. That's what the multiplication sign means, groups of. So 30 is 3 groups of 10. 810 is 8 groups of 10. 74,320 is 7,432 groups of 10. 8,500 is 850 groups of 10. So each of those numbers with a ones digit 0 is a multiple of 10. 3 multiples of 10, 8 multiples of 10, 7,432 multiples of 10, 850 multiples of 10. What would be the very first number in counting order with a ones digit of 0? Well, the first number that has a ones digit of 0 is 10 itself, which is 1 times 10. What would be the next number that would have a ones digit of 0 in counting order of all numbers? That's 20. And that would have ones digit of 0, and 20 is 2 multiples of 10. The third number that would have a ones digit 0 is 30, which is 3 multiples of 10. The fourth number with a ones digit 0 is 40, which is 4 multiples of 10. Okay, we can keep this going. The fifth one would be 50, which is 5 multiples of 10. The 17th number with a ones digit 0 would be, which is 17 multiples of 10. So the nth, so some undetermined number with a ones digit of 0 would be n times 10. Whatever that number is, right? So all whole numbers that have a ones digit 0 are multiples of 10. What would be the reverse of that statement? Well, the reverse would be all multiples of 10 are whole numbers with ones digit 0. Is that statement true? Are all multiples of 10 whole numbers with ones digit 0? Well, let's list multiples of 10. Remember, when you're listing multiples, you're just skip counting by tens, right? So the first one would be 10. That's 10 times 1, 10 times 2, 20, 10 times 3, 30, 10 times 4, 40, 10 times 5, 50, 10 times 6, 60, 10 times 7, 70, and on it goes. Okay, multiples of 10. 10, 20, 30, 40, 50, 60, 70. Are they all whole numbers with ones digit 0? Yes. Yes. Every single one is. Okay. So not only is this original statement true, that all whole numbers with ones digit 0 are multiples of 10, that is true, but its reverse statement is also a true statement. All multiples of 10 are whole numbers with a ones digit of 0. This statement that we've just created here is called the divisibility rule for determining if a number is divisible by 10. If a number will divide by 10, it will have a ones digit of 0. That's a general rule. When somebody asks you, is a certain number divisible by 10? Can you divide it by 10? It will always end with 0 in the ones place. Okay, so when we're talking about multiples, we are actually also talking about numbers that are divisible by that number. In this case, if we're talking multiples of 10, we're talking about numbers that are divisible by 10. Okay, and those are numbers that have a ones digit 0. And this is the term that I just introduced a minute ago. That's called a divisibility rule for 10. That's how we know if a number is divisible or will divide by 10. Okay? So I'm going to give you a couple of numbers, and you tell me if these numbers would be divisible by 10. 320. Well, according to our divisibility rule, any numbers that are multiples of 10 would be divisible by 10. In other words, any numbers that have a ones digit 0 would be divisible by 10. Okay, so this number would be 32 groups of 10. So it is a multiple of 10. It has ones digit 0. So yes, this number would be divisible by 10. You could divide 320 by 10, and you get 32. Okay, what about this number? 165. Is that divisible by 10? Well, right away we can see no. It does not have a ones digit of 0. So no, it is not divisible by 10. What about this number? It has a ones digit of 0. So yes, it is divisible by 10. If you divided 30 by 10, you would get 3. Because 30 is 3 groups of 10. Okay, let's think about divisibility by 2 then, this time. How can you tell if a number is divisible by 2? Not by 10, by 2 this time. Just by looking at its ones digit. Because that's what we did to determine if a number is divisible by 10. We look at its ones digit. Is there a way to do that and figure out if a number is divisible by or can be divided by 2? Well, let's look at this number. 32. Is this divisible by 2? In other words, could we divide it by 2? Could we divide it in half? Yes, we could. It would be divisible by 2 because half of 32 is, give you time to figure it out, 16. Okay? What do you notice about this number, the digit in the ones place? Is it that it ends in a 2? Well, let's try another one and let's see. Here's another example. 34. Is this number divisible by 2? Can we divide it by 2? Well, what's half of 34? 17. Yes, we can. 34 is divisible by 2. Look at its ones digit. Okay, well, let's try another one. 36. Is it divisible by 2? Can we divide 36 in half? Yes, we can. Get 18. So 36 is divisible by 2. Look at its ones digit. Are you starting to see a pattern here? Let's try 38. Is it divisible by 2? Can you divide 38 into 2 equal groups? In other words, can you divide it in half? Yes. 19 would be in each group. Look at its ones digit. Let's try the next one. 40. Is it divisible by 2? Can I divide 40 into 2 equal groups? How many would be in each group? 20. Right. Oh, look at its ones digit. Are you starting to see a pattern for when numbers can be divided by 2? Let's try another one. 41 divided by 2. Can I divide 41 into 2 equal groups? No, I can't. No, I didn't get a whole number. Okay, I'd get a decimal. Okay. What do you notice about the digit in the ones place? The numbers that can be divided evenly by 2 and the number that cannot be divided evenly by 2. Our numbers are ending with 2, 4, 6, 8, or 0. If numbers can be divisible by 2. Numbers that end in an odd number, like 1, 3, 5, 7, or 9, are not divisible by 2. So what would you say is the divisibility rule to determine whether a number is divisible by 2? It will end with a 0, 2, 4, 6, 8. In other words, it will be an even number. Okay, so here are some numbers. Let's see if we can sort them into the Venn diagram to determine if these numbers are divisible by 2, or if these numbers are divisible by 5, or if these numbers maybe are divisible by both, then they'll go in the center section. Okay? Well, think about what a number would have to end with to be divisible by 5. In other words, remember divisible means it's a multiple of 5. And multiples of 2. Okay. Well, 3. Is 3 divisible by 2? No, because it's odd. Is it divisible by 5? What would it have to end with if it's divisible by 5? Let's think of multiples of 5. Multiples of 5 would be numbers like 5, 10, wait, skip counting by 5, 15, 20, 25, 30, and on and on and on. What do you notice that those numbers all end with? 5s or zeros, right? For a number to be divisible by 5, it's a multiple of 5. It will end with a 5 or a 0. Okay? Okay, so does 3? No? Right, so no, 3 doesn't belong in either of those circles. What about 10? Is 10 divisible by 2? Numbers that are divisible by 2 will end with 0, 2, 4, 6, 8 in the ones place. Well, that does. So 10 would go here, divisible by 2. What about divisible by 5? Can you divide 10 by 5? Well, does it end with a 5 or a 0? Yes, it does. Oh, so 10 is divisible by 2 and by 5. It's going to go in the middle. It's divisible by both. Okay, what about that one? What about 12? Divisible by 2? Yep, it ends with an even number, so yes it is. Is it divisible by 5? Does it end with a 0 or a 5? Nope, so it's just divisible by 2. What about 13? Is it divisible by 2? Nope. Doesn't end with 0, 2, 4, 6, 8. What about divisible by 5? Does it end with a 0 or a 5? Nope. Doesn't belong up there at all. What about 14? Is it divisible by 2? Yes, it ends. It has an even number in the ones place. Is it divisible by 5? Does it end with a 0 or 5? Nope. 14 is done. 15. Divisible by 2? No. Doesn't end with a 0, 2, 4, 6, 8. Is it divisible by 5? Yes. It ends with 5. So 15 belongs here. Okay, you go ahead and finish the last 5, and then stop the video to do that, and then restart the video and check your answers. Okay, there are the final answers. Check your own and see how you did.